So to go over anything, I know we had one person just log in. I'm going to go over everything right quick. The homework is due on, when did I make it? The 4th. And the test on chapter 3 or I'm sorry, it's chapter 5. I get y'all mixed up with 109 all the time. On chapter 5.1, 5.2, and 5.3 is due Friday. When is that? The 6th. Is that what I just told y'all?
Yes.
Okay. So get that done. You have one day to, which was supposed to be today, but since the power and all, since it was a total cluster, the last couple of days I've extended it to the 4th. So question day will be 4th. We did cover the test, so I don't have to do that. And that's it on that. So some of y'all have a reprieve, especially some of y'all that had power problems. Here is the most important section of Math 110 right there. Okay. Now let me tell you what's going to happen. I'm going to try to cover this and leave about a week for 7.1 and 7.8. Okay. Because that is not really detrimental to you. Now 7.8 is for calculus, but determinants and Cramer's rule is not really important for calculus. Systems of equation is semi. So if we have a week, Monday, Wednesday, and Friday to go over this, then I can get it in. So I'm going to try to get this done in the next couple of weeks. Now we're going to be doing some skipping. I'm going to be doing some I may not spend a lot of time. So do not go ahead of me. Okay, do not go ahead of me. Next to completing the square and some of the other things, the vertical and horizontal shifting. The next most important is the logarithms. Okay, so we're going to spend times now. Before we go into logarithms, I'm going to review a little bit over your basic exponentials. Okay, so what I'm going to do is I'm going to pull that up right quick. Exponential properties. And I'm just going to pull up, let's see, where's a good one? Let's look in there to see what that looks like.
You have a work email.
That looks good. Oh, I hate when I do that. Let me open the save image as exponential. Exponential properties. Let me send that to y'all. Give me a second, I'm gonna send it to y'all. Okay, I'm uploading it right now. And I'm gonna send it to y'all via chat. You can print it out. There it is, or put it on a Word document. I'm gonna put it on a Word document. Well, I'm just gonna go over it. Okay. So I'll just go over it with the handy dandy do-jigger here. All right. Now I know I cannot stand to go over new material while we're having the test, but the way that everything's worked out, I've already covered the test. It was only 3 sections. I spent a lot of time on those 3 sections. I think I spent like a day or 2 on each section. So I think y'all should be able to do it. The only reason y'all haven't done it probably is because, like I said, some of your power have been knocked out. So we'll just take it in stride. All right. your exponential laws. Why are we going over exponential laws? Because logarithms are glorified exponents. Okay? Logs are glorified exponents. Okay? And the same properties that you learned with exponents apply to logarithms. Okay, so that's why you've got to review the exponential laws. All right? A to the n times a to the m is equal to a to the n plus m. That is called the product rule. When the bases are the same and you are multiplying, you add the exponents. When the bases are the same and you are dividing, you subtract the exponents, which is called the quotient rule. When you have an exponent raised to another exponent, you use the product rule. Okay? Now, these three rules pretty much have to do with the actual calculation of exponents. Okay, so they actually are anything having to do with calculating exponents. The next two or three is basically how an exponent looks. You've got the inverse rule. Oops, I'm going the wrong way. The inverse rule says 1 over a to the negative n, or a to the negative n over 1. You flip it, and that's called the inverse rule. One over a to the n becomes a to the n over 1. And 1 over a to the n becomes, a to the negative n over 1 becomes 1 over a to the n. And that's called the inverse rule. And the inverse rule basically gets rid of a negative what? Exponent. Okay, the way it looks. Now, you may go over to, we were talking about Japan earlier. You may go over to Japan and you get rid of the exponent. They may say, why'd you do that? Okay. Some cultures say they don't want a negative exponent. Some cultures don't care. Okay. Just letting you know that this is how something looks. You don't use it very much with calculations. You use it for the end product or the end solution, how it looks. Okay. The next one is called the inverse power rule. The inverse power rule says a to the n over a to the m raised to the negative w, you can use any letters you want to, is equal to a to the m over a to the n raised to the w power. And you're basically switching a negative exponent to a positive exponent by flipping what's inside the parentheses. Again, is for looks, because you don't want to use a negative exponent, or you don't want to see a negative exponent. So that's on how something looks, the aesthetics of a negative exponent. And then the last two that I really care about is different forms. Well, one is forms and the other is equation. Okay, forms means radical. X to the 1/2 power is equal to the square root of x to the 1st power, meaning exponent over index. If I want to rewrite the 3rd root of x to the 1st power, I just change it to x to the 1/3. Now this is very important in calculus, because in calculus there is no radical in calculus. Okay? When you're dealing with calculus problems, you're taking the antiderivative or the derivative. Calculus and radicals don't mix. So it's always good to be able to change your radical into an exponent. And the way you do that is you put the exponent over the index and you raise it to that power. And when you're dealing with equations, solving equations with an exponent, if you have 2 to the 4th power is equal to 2 to the x power, if the bases are the same, then you can set the exponents equal to each other. Okay. So all of these things that I just went over between the exponential laws, the aesthetic laws for exponentials, and the radical, it's called a rational exponent, and solving an equation. All of those you will see in chapter 6 in some form, some way. And hopefully all of you probably said, oh yeah, I remember that. Oh yeah, I remember that. And then you got here and you go, I've never seen that before. And I sure hadn't seen that before. Okay, that's usually the way it goes. All right, so question on any of that so far? And hopefully y'all remember most of it. Now, you also have your exponential graph. F of x is equal to, I'm just going to use 2 to the x power. Let me go ahead and show you right quick. I'm going to show you 2 graphs. Y is equal to 2 to the x power. And log of x. Log of x. And we'll do the log of x in a dashed form or dark. There we go. And of course, you're going to add this to your parent graphs. Okay, so this is 1. That's f of x is equal to 2 to the x power, and your f of x is equal to log of x is going to be equal to, let's see, hold on. You can't take the log of a negative number, so it's 0. That should be 0. Hold on a second. Y is equal to, yeah, make sure I put it in there right. Let me go to zoom in. Yes, like negative 1 point. I was going to put it at 1, but it looks like that. Okay. All right. Now, the reason you need to know this is because they're going to ask you some questions like this. What is f of x? Now let's see if you can do it with what you've learned in the past 2 units. F of x is equal to 2 to the x minus 1. And what is that? What does that negative 1 mean? Oh well, so much for what I've taught. What does the negative 1 mean? Shift 1 to the right. Thank you, Mr. Cash. You give me hope. Yes. So 1 to the right. So your function looks like that. Okay. So what about f of x is equal to 2x plus 1 minus 1. Then, of course, that would be a horizontal shift of 1 to the, 1 to the right and 1 what? Down. Okay, you can apply that to both of these. So I'm really not going to spend a lot of time when we do go over the sections of these two, because it should be like, y'all should be like, oh yeah, I know how to do that. F of x is equal to log x plus 2. Well, 1, 2. F of x is equal to log of x plus 2 minus 1. Well, it's going to be 1 down. Well, let's make that a plus because I'm running out of room. Plus 1. So I should not have to spend a lot of time on the graphs of these two. Okay? Because why? Because I've hammered unit 1 and unit 2 on vertical and horizontal shifts to the point all of you should be saying to yourself, oh, I see. You should be saying that because we spent so much time on completing the square and vertical and horizontal shifts. So hopefully you see that. You also need to make sure you understand this one. Two to the negative x means that you're coming downward. Okay, now that's a decreasing function. That means decay, half-life. And this is compound interest. Okay, and we're going to see that later. We're going to see that in the sections. All right, so make sure you understand, the negative x right there. That means it's going in this direction. Now, should you have seen this before? Pretty much all of this you should have seen before, but I'm starting to touch a little bit on what we're going into right here, making the transition between what you review and what you should be reviewing and what we're going into. All right, so when you go and look in the homework or the syllabus right here, you see exponential functions. And then you see logarithms and their properties. And I'm going to go ahead and pull up the logarithms, because what should you have? I tell you what you should have in this section. This is what you should have. You should have 3 index cards. Okay, I know I'm talking to maybe 3 people in here that's going to do this, but the one index card, exponentials. I'm sorry, hold on. Exponential laws, properties, what I just showed you. The next one you should have graphs of exponential and logarithm. What I just showed you right there. Okay. And then the next one, you should have the log properties. Now I'm going to go ahead and show them to you and send them to you, to where some of y'all that, you know, it's a lot of work, there's a lot of work involved, you can print them out and just put them on the index card. Okay, let's go ahead and find those. It's real hard. It's real, you just go in and type in log properties. It's real hard. Look at their cheat sheet. There's a good one right there. So we'll call that log. And then I'll send that to you. Things I do for y'all. There you go. Now you can find a shorter, squattier one. That's up to you. Here's one that's got both, I think, logarithms and exponents. Might not, I don't know. You go through there and look. I sent you one. There's one. That's one. And so on. But I'm going to go back to this one. And I'm going to highlight that one right there. I can't highlight it. Let's see. Well, I'm just going to write it. Definition of a logarithm. Well, that's the property. That's the. I hate it when they don't put the definition of a logarithm on here. Hold on. Definition of a log. And they always write it backwards from the way I do it. There we go. Put this on that property of logs. This is the most important one on logarithms. Number one. Number one, definition of a logarithm. Definition of a logarithm. Y is equal to log base A of X. You can rewrite that as X is equal to A to the Y. So I can go from an exponent to a logarithm, or I can go from a logarithm to an exponent. This is the basis for logarithms. If you don't learn this, then you might as well just go ahead and just not take the test. Okay, because everything that I'm going to teach you in chapter 6 is based on the properties that I showed you, but before you learn the properties, you've got to learn this. Okay? So make sure you have this on that index card with the properties of logarithms. So you should have 3 index cards in this chapter. Okay? Now, and you see there's some good pictures of logarithms, and you can look those up and all that good stuff. I don't really care about that. Let me go to definition of a logarithm. Logarithms and their properties probably right in here. 6.3. So I'm going to go right there right quick and pull in a couple. 6.3. And I bet you I haven't. No, I haven't. Sucks. Assignment manager. Let's see. We need to make 6. All of chapter 6. Go ahead and open it up. But please do not go ahead of me, all right? Because right now I haven't even started anything. I'm just going to show you a couple. And right now y'all should be finishing up the last section. 6.5, 6.6. And assigned and update. And hopefully most of y'all should remember logarithms. Let me ask you this. How many of you in the class, I want you to raise your hands, how many of you have never seen logarithms before? Never seen logarithms. Come on, don't be shy. I'm going to give everybody a few seconds to think about it. How many of you? Right now we got 3 people, 3 out of 15. Is there any more? Okay, so we have some people that haven't seen logarithms before. Usually there's a few in each class. So make sure you pay attention. Assignments, I think 6.3 is where they actually start. Let me find a definition of a logarithm right quick. Show you what it looks like. There's one right there. All right, so it says 7 to the second power is equal to 49. And it says write it in logarithmic form. Well, you got your handy dandy logarithm right there, definition of a logarithm. And it looks like this side over here. It's an exponent. So you put 7 to the second is equal to 49. And you draw an arrow up there, an arrow right there, and an arrow right there. And then you plug in what? Plug and chug. Which one's Y? You can take your hands down now.
The Y
okay.
is 2.
I have seen them, but haven't really understood them. Mr. Mulata, that is the #1 answer. A lot of students, let me ask you this, okay? Take your hands down. Mr. Bates, take your hands down. How many of you have seen logarithms and never understood them? See? Okay, that's good. And then the rest of y'all invented them, right? All right, and yes, that is exponent. So 2, so I'm going to use colors here because y'all know I love to use colors. That's that one. That's that one. And that's that one. So I'm going to rewrite it. Y is 2 log A is what? 7, base 7 of 49. And now I've just written a logarithm as an exponent as a logarithm. I just rewrote. Did I say calculate? No. I said rewrote. Oh, God. I can't even talk. I rewrote. Say that 5 times fast. I rewrote an exponent as a logarithm. That's all I did. Okay? I rewrote an exponent as a logarithm. And you can go both ways. Now, why do you need to learn this? Because that's the basis of what a logarithm is. A logarithm is just an exponent rewritten. A logarithm is an exponent rewritten. Now, since it is rewritten, there are some things that are different as far as, being able to manipulate equations. And that's one of the reasons you learn logarithms, is because you can do more things with a logarithm than you can with an exponent as far as solving equations, and vice versa. There's sometimes that you don't need to do stuff, so you change it into an exponent and just solve it with an exponent. Sometimes you need it, depending on what you're doing. And that plays into the calculus. Okay? I'm trying to catch up on everybody. Okay. Mr. Bates, take your hand down, please. I don't think you have a question. All right, so let's go the other way. Well, let's type in the answer. 2 is equal to log base 7 of 49. Now, let me go ahead and tell you something else while we're on the subject. No, I don't want the next question. There we go. Write this question down, or write the way I just wrote that. You see that log base 7 of 49? Does everybody see that? This cannot be calculated with a calculator. Why? Because the calculator has only 2 buttons. What are they? LOG and LN. LOG is called the LOG button. And that LN is called the natural log. Now, in order for you to calculate on a calculator, it has to be either the LOG or the natural log. What does that mean, Hubert? That means that the LOG, you have to have LOG base 10 or log base e. The log is log base 10. The natural log is log base e. Now, you don't really need to know the difference between the two right now. All you need to know is that all of the properties that you use with log, you can use with natural log, and you will get the same answer. The numbers may look different, but you'll get the same answer. Okay? It's kind of like this. What's 50 over 100? Well, the same as 4 over 8. What are both of those? What's the answer to both of those? 1/2. That's the answer. These are two different ways to write the answer. Okay? Does everybody understand that? That you can get the same answer using log base 10 or log base e, just like you can get the same answer with 50 over 100 and 4/8. This is not log base 10 or log base e. Therefore, you have to use what's called the change base formula. And it's on your properties. It's called the change base formula. And I'm just going to show you how to do this as an example, because once I show you how to do it, you're going to say, oh, that's easy. Log base 7 of 49 will give us log base 10 of 49 over log base 10 of 7, or natural log of 49 over the natural log of 7. I just used the change base formula. The change base formula says that if you have a different base right here, I'm going to mark this in red or pink, because that's not good. If you have a base that is not a 10 or a E, then you have to change it to a, and this right here is log base E of 49 over log base E of 7. Okay, you have to change it to that, or you have to change it to that. So you need to write this down. This is called the change base formula. And you'll see it in your properties, but it ain't gonna make any sense unless you see an actual, example. Now, a lot of people say, well, Hubert, which one do you use? It doesn't matter. You'll see me use log and you'll see me use natural log. It doesn't matter. You can pick which one you like, or you can learn both of them. It doesn't matter, because you get the same answer. Okay? If I tell you to rewrite 1/2, most of you are going to pick 4 over 8 or 5 over 10. Some of you pick 1 over 2. But 1/2 is 1/2. It doesn't matter. Okay? So you don't need to get hung up on, is there a difference between log log base 10 or log base e? No, there's no difference. It's just a different way of writing it. Okay, so think of these two right here, log and natural log. Different way of writing. You get the same answer. Now, I've covered about 2 or 3 sections in chapter 6. And right now, y'all are all over the place like a ping pong ball. That's fine, because we're going to iron all the wrinkles out as we go. I'm just giving you some kind of an introduction. All right. Right now, I don't want you doing any homework in chapter 6. I want you to work on 3 things for chapter 6. There they are right there. If you've done all your homework and the test in chapter 5, if you've done that, then I want you, between now and Wednesday, I do want you, and I'm going to shut it off right now. I'm going to go ahead and finish this. I want you to go ahead and do this. If you haven't got any homework and any tests to do, I want you working on this. I want you to take those files that I sent, or files that you use, whatever files you want to, and I want you to go and pull up any pictures of these that you want to, and I want you to put them on an index card, and I want you to have 3 of them. And that's your homework for those that have finished chapter 5. That's your homework. If not, work on chapter 5 and then do that in your spare time. All right, I'm going to shut this off, and I'm going to shut down the recording.